A7 is asking if tan of x is differentiable at pi by 2. So when we're looking at a function like this and determining whether or not we're differentiable, we look at two properties. One, domain restrictions for f of x, and two, domain restrictions for f prime of x. So here, if we're looking at tan is sine of x over cos of x. And if we look at the derivative, which is secant squared of x, this equals 1 over cos squared of x. So our domain restrictions, we look at these, the domain restrictions are cos of x cannot equal 0. Well, when does cos of x equal 0? I do a quick little cheeky draw of cos of x. It's at pi by 2 and 3 pi by 2. And we want to know if pi by 2, if we're differentiable, but here we can see that cos of x equals 0 at pi by 2. So it is a domain restriction. X cannot equal pi by 2, so we are not differentiable. Pi by 2. Okay. Now for A8, we're looking at a grain silo and we're filling a truck. So here we're given a grain silo, filling a truck. And the grain's coming out into here. And it's filling the truck. And it tells us the rate at which it's filling the truck. And we want to determine the definite integrand or the definite integral that would solve for the weight of the grain required to fill the truck if it took 10 seconds to fill the truck. So if it took 10 seconds to fill the truck, what that means is it's taking from 0 to 10 seconds. And they tell us that the rate is 3x squared. And we take the derivative of this with respect to x, and that gives us our weight. Why is this true? Well, we were told if we were given a rate function, dw by dx, a rate function, and we take the definite integral from a to b with respect to x, this is equal to the weight of material transferred between A time A and B. So our integral would be 0 to 10 3x squared dx. Now, why am I using dx here instead of tx? Well, they gave the equation with a variable x. It's weird. Normally, when it's seconds, we would use the the variable t, but we have to use the variable that they give us. Okay, now for A9, we're looking at the limit as a goes to infinity of this expression. And here what we're going to do is when our variable, if we just plug this in naively, we get infinity minus infinity over infinity. So we need to multiply by something to get rid of all those infinities. We're going to multiply by the largest power on the bottom. So this is going to be equal to x squared minus 3x over 2x squared times 1 over x squared divided by 1 over x squared, giving me the limit as x goes to infinity of 1 minus 3 over x all over 2. Well, this goes to 1, this goes to 0, this goes to 2. So this is going to equal 1 minus 0 over 2, which is 1 half. And finally, we're going to look at A10. So for A10, we're asked to find the linearization of cos of x about x equals 0. So for the linearization, what that is asking us to do is it's asking us to create a first-ordered Taylor's approximation for cos of x about x equals 0, or L of x equals f of a plus f prime of a times x minus a. And here, this is telling us that a equals 0. So f of a equals cos, or f of x equals cos of x, f prime of x equals minus sine of x, f of 1, or f of 0, sorry, is equal to cos of 0, which equals 1, and f prime of 0 equals minus sine of 0, which equals 0. So this tells me that L of x equals 1 plus 0 times x minus 0, which is equal to 1. So L of x equals 1. And that completes part